Hi, my name is Shahroz Ahmed, and in this video I'm going to discuss a topic of Calculus 1, that is limits and continuity. So in order to understand the concept of limits and continuity, let's suppose that we have a function f of x equals to x minus 1 over x minus 1, where we say that x is not equal to 1. So let me just make its graph, and then I'll show you how I can explain its limit. So the graph of this function will look like this. Here's the x-axis, and we have the y-axis over here. This is f of x. I can write it over here, and this is. So I'll just draw the graph of this function. That will be a horizontal line at f of x equals to 1, like this. All right, a circle over here. I'll just let you know the meaning of this small circle. So this will be the graph of this function, and over here at this point the value of x is equal to 1. So this function has no value at x equals to 1. So that's why I have put an empty circle over here. It means that the value of f of x does not exist at x equals to 1. But if we approach this point from the left side, that will be, you can say, 0.999999. Or if you approach this point from the right side, you can say it as 1.0000001. So this is the number that will be almost equal to 1 if you approach it from the right side, and this is the number that will be approximately equal to 1 if you approach it from the left side. So the value of the function exists if we approach to 1, but it does not exist at 1. So that's why we will say that the limit for this function does not exist at 1, but the value of the function f of x is equal to 1 when x approaches 1. X approaches 1 means it could be 0.999 or 1.00001. If you approach it from the left side, it will be 0.999. If you approach it from the right side, it will be 1.001. So in order to represent the approach towards 1 from the left side, we will write it as 1 with a negative at the top. It means that we are approaching this point from the left side, and if we are approaching this point from the right side, I'll write 1 with a positive. So 1 plus means we are approaching the number from the right side, and 1 negative means we are approaching the number from the left side. So this is how we can represent the limit. Now let's consider and let's see another example. So here we have a function g of x. So such functions are called the piecewise function. Okay, so for this function, g of x is x square when x is not equal to 2, and the value of g of x is equal to 1 when x is equal to 2. So let's see the graph of this function, then we will explain about the limits, and we will check whether for this function the limit exists or not, and what will be the conditions for the limit to exist. Okay, so the graph of this function will look like this. We'll have a y-axis over here, and this is the x-axis. The graph of this function is at 2. I'll just put a circle here. So at this point, the value of x is 2. This is g of x in the y-axis, and this is x in the x-axis. So this is the graph for x square. So the values for x square exist for all real numbers except 2. At 2, when x is equal to 2, the value is equal to 1. So over here we have 4, over here we have 1. So when x is equal to 2, the value of g of x is equal to 1, and except 2, the value of g of x is basically equal to x square. So if we approach 2 from the left side, and if we approach 2 from the right side, we must get the same answer for the limits to exist. But in this case, we can say that if the g of x is basically equal to 4 when x approaches to 2, either from left side or from the right side, but g of x will be equal to 1 when x is equal to 2. So if you approach it from the left side or if you approach from the right side, the value of g of x will be equal to 4. But if you are at 2, then the value of g of x will be equal to 1. So this is the concept for the piecewise function and for the limits to occur or not. Now the next subtopic that we have to discuss for the limit, we will see what is the condition for which the limit exists and what are the conditions for which the limit does not exist. So for that purpose, I'll just make a graph and I'll see whether the limit exists or not. So we have to discuss the condition for the limit to exist. So let's suppose we have a function f of x. So if the limit x approaches to a constant number f of x, we'll get an answer. So if we approach this constant from the left side and if we approach this constant from the right side, the values of the functions should be same. So let's suppose if we approach x equals to 2 and the value of f of x is 4. So if we approach 2 from the left side, the value of f of x should be 4. And if we approach from the 2 from the right side, the value of f of x should also be equal to 4. If that happens, then we can say the limit exists. Otherwise, the limit does not exist. So I'll draw a graph of a function and we will check whether the limit exists or not. Alright, so this is the graph. So we have to check the limit at x approaches to 2. So the value of f of x when x approaches to 2 from the left side, like from this side, the value of f of x is equal to 3. And when we approach 2 from the right side, so I'll just write limit x approaches to 2 plus f of x will be equal to, so if you approach it from the right side, the value of f of x will be equal to 1. So in this case, as you can see, the limit approaching from the left side and from the right side are not same, so we can say that the limit does not exist for this function. So I'll just write it over here. Limit x approaches to 2 negative, f of x is not equal to limit x approaches to 2 positive of f of x. So the value is not equal to, the values are not equal, so the limit does not exist. Alright, so this is how we can check the limit. So after this one, we will discuss another condition for the limit to exist or to not exist. Okay, so I'll write the point over here. The limit of a function does not exist at a number if the function is approaching infinity. If the function is approaching infinity. Now I can show you the graph like where the function approaches infinity. Okay, so let's suppose this is the y-axis and here we have the x-axis. This value is 2 over here. I'll just draw a dotted line. So there's a function. The graph of the function looks like this. Like this. So it's like this. So as you can approach 2 from the left side, you are approaching positive infinity. As you approach 2 from the right side, you are approaching negative infinity. In both cases, your function is approaching infinity. So for this function, the limit does not exist. Or you can simply write limit x approaches to 2. For this function, let's suppose this function is f of x. So limit x approaches to 2 for f of x is equal to infinity, hence limit does not exist. So the conditions for the limit to exist will be the limit from the left side and the right side should be equal, and the limit should not approach infinity. The value of the function should not approach infinity. So these are the two conditions for which the limit exists, otherwise they don't. Now we'll see a couple of example questions to understand the concept of limits in a better way. Alright, so this question is about the limits. It says, what is a reasonable estimate for the limit x approaches to 1 of g of x? So this is the graph of the function g of x, and we have to check the limit where x approaches to 1. So x approaches to 1 over here. So at this point the value of graph should be equal to somewhere be equal to negative 1.5. So we will see in the options whether this number is present or not. Okay, so we have the options of negative 1.9, no, negative 1.4, yep, this is the closest number to negative 1.5, so we'll choose this one and check, and this is correct. So you just have to see the graph and check what's the answer against x equals to 1. Now let's see for this one. In this question it says what is the reasonable estimate for x approaches to 1 of g of x? Now in this case we are not saying x equals to 1. We are not seeing this value, we are seeing where x approaches to 1. So this is 1, and on the graph we approach it from the left side, and from the right side we will see this number. So this number is basically equal to 4. So our answer should be equal to 4 when x approaches to 1. If it is x equal to 1, then we will be giving the answer like 1.8 something, but because over here it's approaching 1, so our answer will be 4. So let's see the options. Okay, so the closest number to 4 is 4.2, so let's check, and it's correct. So this is how you can check the answer for the limits. Now let's move on to the next question. Okay, now see this number. What is the reasonable estimate for limit x approaches to 3? So this is 3. If you approach 3 from the left side, you'll get 4 as the answer. If you approach 3 from the left side, it will be equal to 4. But if you approach 3 from the right side, like from here, your answer will be equal to negative 3. So as you can see, these two numbers are not equals, and so for the limits to exist, they must be equal. The answers must be equal when we approach the number from the left side and from the right side. So for this one we'll say the limit does not exist. So let's check the answer. Okay, so here's the answer, the limit does not exist. Let's check, and it's correct. Okay, so now let's see if we have any other question to work on. Alright, so let's see this one. It says, is it always true that limit x approaches to a f of x is equal to f of a? Well, no, in this case it's not true, because you can see like the example that we just did over here, this one. In this case the answer when x approaches to 1 was 4, but the answer at x equals to 1 was 1.8. So it's not always true. So the answer for this one will be not always true, no, and it's correct. So these are some of the sample questions that I wanted to do in front of you for the limits and continuity. So this is it for this video, and I hope you liked it. Thank you so much for watching.